greenhouses produces plants and helps plants grow and produce fruits and vegetables all around the season. They require fans to cool down the plants, and they require lights to keep them warm. We can bring automation to this process by using some sensors that sense the temperature or humidity, and based on those values we can write logics to turn on the lights or turn off the lights, and turn on the fans or turn off the fans automatically. So that's what we try to do in this project using IoT based solution. We also use a cloud-based solution to form a dashboard on the cloud that can be viewed from any device at any time and get the real-time update of the situation that is there in the greenhouse in real time.
So in our IoT and cloud-based smart greenhouse project, we plant a sensor in the greenhouse. This sensor collects data, temperature, and humidity. After collecting that data, it passes it on to our microcontroller, which is the ESP32 we are using here. And that is connected to a laptop, which actually just provides it with a Wi-Fi connection. That data is uploaded to the Arduino IoT cloud. So now, in real time, the data is being kept within the cloud, and if we're using smartphones, PCs, any kind of devices, and we are connected to this platform, and we are logged into our own company's account, from there we can see the readings and also the dashboard where in real time the values are being updated. From this central computer where the ESP32 is connected, we can push codes into the ESP32. Say we want to do something with the temperature or the humidity, we can control it using this controller. That same thing we can also do with other PCs over the cloud that has the access to do that. We have also connected the ESP32 to some tools such as a fan and some lights. Actually, for our presentation, we have connected it to one light. And we use the value of the temperature here. If the temperature is too low and the plants are feeling very cold, in that case, the light is turned on, showing that we can use a lot of lights together automatically to turn it on and sort of heat up the plants. And if it goes too high, the lights will turn off and it becomes too hot. So after a certain threshold, the fan will start. So that sort of shows that it can cool down the plants. So that's why we're calling it a smart.
This is our cloud computing project about IoT things and the cloud-based smart greenhouse. So the main idea of our cloud computing project is using ESP32 to develop a IoT things to monitor inside the environment of a greenhouse. So this is our ESP32 module, and this is temperature and humidity and sensors, and this is LED light, and this is small file. Because the limitation of the electricity and the voltage, so we cannot use the DC model. So we instead of use this one. We use Arduino IoT cloud to write code and deploy our project onto the cloud. And we also connected our Wi-Fi with our project in Arduino IoT cloud. After we deploy our project on the cloud, so we can use our mobile phone and the laptop to see the information change in real time. And wherever you're in, you can see the change. This is our Arduino IoT dashboard, and you can see their temperature and the humidity and lights indicated. And you also can see the temperature history changing. This is our interface on the mobile life, and you can see there when temperature goes down, the light is turned on, and when temperature comes to the 24, so the lights are closed. So in the future, if you want to use some data from this, you can log them in this file, and this is our log monitor. And we will log our temperature and humidity data on that. If you want to use that in the future application, you can drag those data from this.
Hello, my name is Hamza Jawaid, and today I'm going to show you the components we have used in our projects and the real-time temperature updates. First, we have used this sensor for sensing the temperature, and the second one is the ESP32 microcontroller, and the server motor as a fan, and the fourth one is the LED. Okay, now I'm going to show the IoT dashboard and real-time temperature. So I will just turn on the fan. You can see that the same thing on the dashboard and the. Okay, now I'm going to show that the temperature is going up. You can see that the temperature is going up, and you can see that the fan has just started.
And as you can see, the temperatures are going up, and right now it's on 24, and there goes our fan, and it's going to continuously move as the temperature goes up above 24. Okay, so right here we have the controller, and it's taking up the temperature and the humidity from the air. So like I said, we are trying to cool the system down. So here we're using the ice, we have ice, and then we have a fan that's blowing so that we cool our greenhouse. So we're gonna wait until the temperatures drop. And fun fact, we can actually see the current temperature changing from our phone as well. I'm gonna show you it. As you can see, it's the same as the one you can see from the laptop. And anyone who's connected to this app can also tell the temperature as it decreases and decreases because it's in real time. So as you can see, the temperatures are decreasing on the dashboard, and like I said, you can also see it from my phone, and it's the same temperature you can see from the laptop. So it dropped down below 24. So as you can see, the fan just stopped working, and then now we're just gonna wait for it to drop below 23, so that we can see our light indicator turning on, and then you can also see the light from the control as well. So as you can see, the temperature is going down, and we can also see from our phone. And I'm gonna ask my colleague as well to show us his phone. Okay. So we're just gonna wait for it to get below 23 so we can see the light turning on. So as the temperature goes down, as you can see, we also have like a temperature history. From my phone, I'm showing it on the live graph, so you can see the temperature is going down. And also from the laptop, as you can see, it's showing a more visible graph than your phone, but the temperature is going down as well. And then like I said, whenever the temperature goes down to 23, the light indicator is going to turn on. So you're going to see this light turning on. We're going to wait and see this light turning on as temperature drops below 23. And as you can see, the graph is also changing. Now you can see the light indicator turning on because the temperatures are below 23. We can also see this from our phone. As you can see, my phone is indicating that the light indicator is on and the temperatures have dropped. As you can see from our phone, it's also indicating the light is on because the temperatures have dropped. And yeah.
Hello again, I'm Sartaj and we have looked into the setup. So here's a tiny recap. You can see that we have the ESP32 controller over here, which is connected to the sensor and the LED light and a servo motor. We couldn't make use of the DCC motor due to power related issues, so we went with the servo motor, and it is sort of a proof of concept that we can make the thing work like this. So what the servo motor represents is cooling fans that are there in the greenhouses, and what this tiny LED light represents is the heating lamps that we have in our greenhouses. So in real life, we would use an 18-inch 120-volt fan like this one, which costs about $170 to $165. And for the lights, we would use a LED grow light, which is about 40 watts and around $70. So let's look at the schematic diagram. We can see here that it looks pretty similar. So with the ESP32, we have connected a sensor, we have connected a motor, and an LED. So here are essentially three circuits with the ESP32 microcontroller. ESP32 microcontrollers usually come with some ground pins, a lot of them, some GPIO pins, quite a huge amount of them, and some 3 volt provider pins and some 5 volt pins. So for the motor, which represents the fan's motor, in this case for proof of concept we have used a servo motor. We have connected it to 5 volt and ground and GPIO pin. For the sensor, we have done the same thing with another pin, but here we provided 3 volts to the sensor because it does not require much. And for the LED lamp, tiny LED, we didn't need any external source for power. We just added it to the GPIO pin, a resistor, and the ground, and it was working. This setup was connected to the central device where we had our Arduino IoT cloud logged in as well, and from this device we could push codes into the microcontroller to test our environment, our setup. We changed our code, and multiple times we had to push the codes and see the changes real time. The central device also provides with a Wi-Fi connection to the setup. So there is usually an agent in the central device, which is Arduino IoT Cloud, which connects this port to the platform, and that way we can push codes into this. And also from the platform we can connect to Wi-Fi, any Wi-Fi that we have around our house, so that this setup is always online. And when this setup is always online, from any remote device, maybe my phone or phone of any of our team members, we can view the temperature changes, humidity changes, and also the state of the fan or the LED on the dashboard real time. So that's the schematic diagram. Moving on, talking a bit about the Arduino IoT Cloud platform. It is a cloud-based platform. It's just like AWS, Amazon Web Services, but it's for Arduino IoT projects. So the cool part is that it comes with a lot of devices other than just Arduino boards. Like it could be any Arduino board, it could be ESP32 boards. It's just like an Arduino IDE, but it's on the cloud, so that's pretty cool. And it's easy to integrate the Arduino devices using that. It's very simple. You don't need anything extra on your setup on your device. You just need that small agent that connects the platform with your port. That's it, and the rest of it is within the cloud. It helps with real-time data management. So as we have seen, like we can see real-time the changes on the dashboard and in other devices all over the world as well. Its user-friendly interface, we will see the interface in a bit. It provides a secure communication, so it uses transport layer security, TLS SSL protocols to keep the communication between the devices and the dashboard and everything secure, right? And it helps us with automation and control. So we can use cloud-based rules, and we have written a lot of codes where we provided some logics within the platform that helped us build into the project, right? So next I'll show the platform a little bit. So this is the platform. As I said, it's almost like any cloud platform, Azure or AWS, but it's for Arduino projects. It's like Arduino IoT cloud. So this is the thing. Bring your IoT projects to life quickly. So that's the whole point of this Arduino IoT cloud project platform. So in our Arduino cloud platform, we needed 3 components. One is the thing, which basically means the variables that we're going to use. Then a sketch, which is the code that we had to write, and the dashboard we built. So these are the 3 components or instances that we needed, and they are connected in some way. For example, the variables are required for the code, so it automatically gets imported in the sketch, and then we can write code and manipulate them any way we want. And then we have the dashboard where we see the result of our codes. In the sketch, we also have a serial monitor, which in the slide we showed looked something like this, which gave us the data. We could later use that data for other purposes, such as data analytics. For the dashboard, it showed those data infographically in real time as well. So let's take a look at the thing component. It has 5 variables. When we create the variables, it automatically gets included into the code. So there's one limitation for this free version that we're using. That limitation is that we can only use 5 variables. And after that, it shows us this plan limits reached, upgrade your plan. So we cannot use 6, we have to use a total of 5 in the free plan. So here it shows us details about the board that we're using. It has an ID, it shows the type of the ESP32C3 board that we're using. And at the moment it's offline because I have disconnected it to make the video. It shows that network. I basically connect the board with my phone's Wi-Fi hotspot, just so that I can access it from our university here anywhere. I can just connect it anytime, just turning on my phone's hotspot. So these 3 things, the variables, the board, and the network, is essential for this project to work. So let's talk a bit about the variables. One is the humidity. It stores the value of humidity readings, so that's what it's for. Similarly, we also have temperature. Then we have the LED one for making the tiny LED here do stuff. And the LED state is for in the dashboard we have a LED indicator, so that is a Boolean variable. So when it's true, this one is on. When it's false, this one is off. You use that as an indicator if our LED is on or off on the dashboard. And the servo control is used for this motor. So when it's true, the motor is turning, and when it's false, the motor is stopped. So here's the dashboard. In desktop it looks like this, in phone it looks like this. So we have the humidity readings here, temperature readings there. We have the light indicator over here. It shows that whether the lights are on or off, and we could add a fan indicator as well, but it essentially does the same thing. The light, this is for the light, this would be for the fan. But as I talked about a limitation, we cannot add more than 5 variables, so we left this one out, and in its place we just left a note, so that when we upgrade the plan in future, we can just add this widget. So we can add the widget from here. Here we have plenty of widgets, so we can add as many widgets as we want from here, but variables are limited, 5 variables. So no matter what widgets we add, the variable 5, it has to be connected with the 5 variables that we have shown here. Also, actually the variables are limited in a sense, like if we upgraded the plan, there would be more cool stuff over here. So for some reason we couldn't use that as well. The reason being that we used the free version, but that's alright. We came up with a pretty decent project using just the free version, right? Next, let's look into the IDE. It's all in the cloud. I have nothing on my PC locally except this tiny thing, which is the Arduino create agent. This is required so that when I connect this ESP32 to my computer through a USB port, that USB port needs to connect it to this platform. So this agent helps initiate and maintain that platform connection with the ESP32, which is connected to our USB port. So this is an editor. It's like Arduino IDE.
Here we have the codes. At first we include all the libraries that we need for our sensors and controllers and the tiny IoT tools that we're using. We set up the pins, then we set up our tools, we set up the cloud, and we make sure that it's running. We make sure that the delay is like in sync with the system. So here we initialize our sensor, then we initialize and allocate some timer to our servo motor that we're using in place of a DC motor. In the loop, the cloud keeps connected and the sensor keeps reading the temperature and humidity. DHT sensor read, this is the function where we actually store our humidity and temperature reading, and we print them out in the serial monitor. And we also control our LED, tiny LED dashboard, and our servo motor using logics in this code. So the logics are related to the temperature. And since we know that temperature and humidity is kind of correlated, so we just use one of them for simplicity. So this logic actually makes changes to the LED light and the dashboard LED indicator. If the temperature is less than 23, those things get triggered and they are on, and if it's greater than 23 or 23, it's off. And for the servo motor, this same thing. It looks a bit complicated, but if it was a DC motor, it would just be an if-else statement with on and off. But since we're using a servo motor, we're just giving it some right and within a loop so that it keeps rotating and it looks like a DC motor. So when the temperature is above 24, it turns on, we see that servo motor doing some activity for a proof of concept, and when it's equal to 24 or less than 24, the servo motor is off. So that's the code. It's pretty simple.
That was all from my part. These were the technical details. Now we will move on to the conclusion, so I would like to pass on the floor.
Alright, now we're going to demonstrate our greenhouse's security system. We're using a camera and some face recognition methods. So this is just a demonstration. We are using an ESP32 cam, which we will connect with our laptop. So this is also a Wi-Fi access point, so we can connect it to this one. Actually, the cable is just to power the device, so it's like it could be connected to any power outlet. We can see that it's connected to this access point of the ESP32 cam, and now we will go to the dashboard of the camera. It's like IP address where we need to go. When we go to the IP address, we can see the camera dashboard. We start streaming, and when we start streaming, we can see, and here it is saying that it's hello subject 1, basically, because he is user 1, and we have enrolled his face. When I try to show myself, I'm also a recognized subject. Deborah, could you help us? We have not enrolled Deborah's face.
After thanking my friend, I will try to briefly summarize what we did in the conclusion. Arduino is often chosen for deploying code to ESP32 modules due to its simplicity, rich library ecosystem, strong community support, and cross-platform compatibility. The Arduino IDE offers a beginner-friendly environment for programming in variant of C++, abstracting complexities and providing easy access to hardware interfacing. And at first, we tried to explain how the system works by drawing a diagram. For the smart greenhouse project, we tried to make a project that allows temperature control with LEDs and fans. Then we showed how the system setup was done. We explained which modules we use and why. We saw that after data received from the sensors was transferred to the cloud, we could access this data from any smart device we want. The Arduino IoT Cloud provides a web-based interface where users can register, manage, and monitor their IoT devices. This interface offers functionalities for configuring device settings, uploading firmware, and visualizing data streams. Since it's a more preferred platform for IoT devices, we deployed the code here. To show that the system is working properly, our friends performed a test by decreasing and increasing the temperature and recorded it on the video. We also showed how the model connections of the device are made on the schematic diagram. We also showed that the ESP32's camera integrated model can perform face detection if a more secure system is developed. All we have to try to multiple attempts of enrolling our face with a different angle. Once it's enrolled, it will detect our face and someone not enrolled in its database when you come in front of our camera. And thank you for listening, guys.